Good morning, everyone. My name is Nikhil Shrestha, and we are Group 2, along with my group member Binod, Madhav, and Uttam. I hope you guys are doing good in this pandemic situation. So, without further ado, let's start our presentation. I'd like to share my screen with you guys. Okay, that's the presentation outline, and the presentation is about the top-down network design methodology about pharma corporation. So the presentation outline is about introduction, goals and constraints, technical goals and trade-off, which will be explained by me, and develop user community, data store, network application, and traffic flow. And mode of addressing and naming will be explained by Madhav. Logical network design and logical network diagram, including addressing and naming, will be explained by Vinod. And then last but not least, routing and switching protocol and security mechanism, along with the conclusion, will be explained by Uttam. So let's go to the next slide. So introduction. Pharma for Pharma is an association group of cooperative pharma that was established to provide the fresh produce to the farmer, and also provide the detail of the product to their clients. So this headquarters is in Brisbane, and the Pharma Corporation do not support cloud-based server as all the servers is located in the Brisbane office, and Pharma for Pharma has a delivery drop fleet which collects from the nearest farmer the product listed in the delivery order and delivers them to the customer. And our group uses like top-down network technology design, which is like highly secure design for the entire project. Okay, then after the business goal and constraints, talking about the business goal. So it's like efficient enterprise network design. So which means that to make very efficient network that doesn't have dependency or under or over allocation of resources and fast data access. It means that the need of fast data access for delivery data or the data. After that, all the data and coming and that need to be implemented in the server, and modularity, stability, and fault tolerance. It is one of the key essential element for designing the enterprise network, and maintaining the high confidentiality, integrity, and accountability. So it means like the farmer was not using the cloud-based servers, so the in-house servers should provide like high bandwidth, and moving to the provide better insight about the price and item detail. So I already explained that they provide the detail about the product to the clients, like the price, like the delivery date, etc., and client usability and maximize the productivity as well. And talking about the constraint, budget constraint. So the budget constraint is about budget constraint, right? So, it's like project is the volume of project is huge, and also the enterprise network is like private network, so in-house server and hardware infrastructure that have like require more budget than the cloud server budget. And talking about the physical infrastructure and resource constraint, all the enterprise network has to be on premises and on site. The state of the art would require comprehensive design, and that's it for business goal and constraints. So let's move to the technical goals and trade-offs. So technical goals, highly confidentiality, integrity, and accountability. So it's like I already discussed, like the network is in-house network, not the cloud space. So technical goals about the providing the highest security to the in-house server, and secure network design That's the same thing, secure network design. Use of high quality hardware, router switches as well, and scalable infrastructure and design. So it depends upon performance, accessibility, availability, and adaptability, and scalable and secure network design. Yeah. So and the trade-offs. Finally, the trade-offs. So in the percent of 100, so the usability will be like 15%, security will be like 25%, availability will be like 30%, and performance will be like 20, and adaptability will be 10. So that's all for my presentation. I hope you guys will stay safe. And now I'd like to hand over the entire presentation to Madhav. Thank you.
Thank you, Nikhil. I would like to continue my slide for the WAF companies based on Queensland, Australia. Here are the list of user communities. There are 7 different users role: data analyst, logistic manager, receptionist, managing director, accountant, secretary, and IT manager. All of them will use the computer, telephone, and printing machine. And here, data analyst he will use the extra hardware called the intelligent software. It's a hardware network application, and then the photocopy will be used by receptionist. And here is a list of the data storage. There are the 8 different data storage. Application layer, application server will use for deployment of the application, used by all communities. Intelligent software server will be used by data analyst, used for data analytics. Database server will use for the data storage and printing, used by all user. Print server will use for the printing and the storing of those data. DNS server will be used for naming of domain. Email server will use for the email. Web server will be used for the host of those company's website. File server will be used for the shared file, and then those are the accessed by all of those users except the intelligent software service. Here the list of the network application. The computer will be used for the web browsing, email, file transfer, and database access. User are the MD, IT manager, accountant, secretary, specialist, and receptionist. Monitoring equipment will use for the delivering monitoring equipment. Example CCTV, and which is used by delivery person. Sometimes it will be used in the delivery truck too. Photocopy machine will be used for make those copy of those documents used by receptionist. Telephone will be used for making call. Barcode scanner will be used for inventory tracking and the items location, used by delivery person and pick packer. Printing machine will be used for print those documents. Here is the table of the traffic flow, and here is the matrix of those user, and then the server which is used. Here the data analyst who will use the application server at the speed of 60 kilobit per second, and then he will only use intelligent software server, which is only used by the data analyst. It will be the 30 kilobit per second. And here at last, at the last of those traffic flow, IT manager, he will use a file server at the rate of 15 kilobit per second. Like this, here is the matrix of those user and the service. And here is the model of addressing and the naming. NET enable server, NAT enable router will be used for the network translation to private to public. DNS server will be used for the domain name to change the IP to the name. Hierarchical network design core layer will consist of the high speed router and switch. Distribution layer used for the policy that focus on implementation of security, traffic, and loading. Access layer is used. They are used by the end user devices are connected to the Ethernet, wired, and wireless access point. Thank you. Now I would like to call Mr. Binod for the rest of the slides.
Thank you, Madhav. Hi, everyone. My name is Vinod, and I would like to continue the slide. The picture that we have seen right now is the network architecture for our company, Farmer for Farmer. It consists of different sections that we have divided the network architecture into the different sections, that is main office, visiting room, waiting room, reception, and warehouse. All of has consists their own PCs, telephones, so that they can get connected to each other and can access the data and information with each other. All the data information are distributed through a distribution layer. And there is one data center. The data center has to gather all the information at one place, and if any of the sections need the data, the data center will simply pass to the distribution layer, and the distribution layer provide the data to all of the sections. And the next one is core layer. The core layer is connected to the distribution layer. The distribution layer and core layer are connected so that if any data are needed, they can exchange with each other. The distribution layer connected to the enterprise edge. That is, the enterprise edge consists of file server, email server, HTTP web server, DNS server. If we want to send any data, we are using a secure protocol. HTTP is one of the secure protocol which is used widely or all across the world. The DNS server helps to change the domain name into the numeric value, that is IP address. The NAT helps to map the helps to map the private IP address to the public, so we can access the web server easily. And the internet service provider helps to provide the internet, which helps to access to the different sources. And we are using some naming and addressing for the different section. For data center, we are using the name as SPPC1, and its IP address is 10.150.1.1, and subnet mask is /24. For reception is computer, for reception is first PC, we are using the RCP1, and IP address is 10.150.6.1 and subnet mask 20, and so on. For main office, we're using the main PC1, and IP address is 10.150.8.1, and subnet mask is /26, and so on. We are using the IP address and naming convention. Thank you.
Hello everybody, my name is Uttam Satya, and I would like to continue our presentation on the topic of logical network design for FOF cooperation using top-down network design methodology. So let me continue with the topic routing and switching protocols. Routing protocols depends how the router communicate with each others. Routing protocols select the best route to send the packets within the network. Here for the routing protocols, we have especially used RIP, EIGRP, and multiple protocol level switching protocol. Talking about the RIP protocol, it is the routing information protocol, and that use the distance vector routing to communicate with the help of routers. And IRP v1 and v2 are the different version of RIP protocols. In RIP v1, there is a single one-way communication, whereas v2 is advanced and it is multicasting for entire routing table. And EIGRP is enhanced interior gateway routing protocol, which is very well designed and has very quick convergence times with minimal traffic network. That's why we have used this EIGRP for this network design. And multiple protocol level switching protocol, switching protocols used in this network design. After this routing protocol, I'll talk about the switching protocols. Switching filters prevent the network traffic of the network that should not be forwarded and prevent forwarding collision. And there are services which uses these switching protocols, includes PLAN. It is a virtual network which allows broadcast of the domain to be defined without the use of routers, and along with that, encapsulation is used. It is added between the routers and switch to create the bridge network and allows the communication between PLAN and SNMP and spanning tree protocols also used and this network design, which allows to communicate and share the data to different devices. And SSH is another services using these switching protocols, which is used for the remote login of the framework. After this switching protocol, I'd like to talk about the security mechanism that we use in this network design. First and foremost, security mechanism is firewall. It is placed between router and switch for the blocking of unauthorized access. And we also use the intrusion detection and prevention system. Intrusion detection and prevention system are the two different systems, where intrusion means it monitor the events that occur in the network, whereas prevention methods helps to control the any unauthorized access, any attack on the network. And virtual private network, it is between the different network, and we use antivirus software as well between the end user to block the different malicious virus and other things. And after that, we use the authentication system as well. This is for the entire network, so that they can be safe from the any types of attack. And lastly, we use the physical security, that is for the server from loss of data and things like that. So these are the points I have described, and at the towards the conclusion of this presentation, so far we talked in the case of FOF case scenario, we gathered information of goals and constraints, technical goals and trade-offs, and we also collect the user communities that are stored in the application traffic flows that can be happen in the FOF company. And we developed the logical network design along with this addressing and naming. And lastly, we discussed the routing and switching protocols that have been used, and also about the security mechanism. So this is the end of the presentation. Thank you.